Good evening or good morning, depends. My name is Xavier P. I will talk about a module, an extension for Snap called SDL4Snap. Let me show you roughly what is Snap. All this extension is available in a GitHub page. So a fast way to go, if I go to Google and I write SDL4Snap. Okay. And here we have a single page that explains what is this module.
Can you share your screen?
Yes.
Can you share your screen?
I'm sorry.
Yeah, that's okay.
Yeah. Thank you.
You're welcome.
Okay. And well, when we are in the GitHub page, what we have here is a little introduction on what is SDL and how is what is this module, this extension called SDL for Snap. SDL is a formal language and is a very old language from the 70s. It was intended for defining communication protocols, but then it is also used for modeling, for specifying simulation models. And here you can find some documentation and even a tutorial. And here, okay, yes, an introduction, an article, and here is a tutorial, and then even is some documentation about SDL. And if I open this link, just to show you that SDL is a standard, and is a standard that defines the SDL itself, and it is also an UML profile. So SDL can be considered an extension of UML. So as you will see, we can use state chart diagrams, UML state chart diagrams, and together with SDL diagrams. And this is what we have here. What we have here is consider the hello world example of two agents. In SDL terminology, the process are agents. So here we have a very simple system that consists of two agents, ping and pong. So the system is the ping pong SDL model. And this ping process can have two states. It starts in idle state, and then it can switch. Oh, sorry. Okay. And it can switch to a running state, and it can remain the running state, and it can go back to the idle, and idle running, idle running. On the other hand, we have another agent. This is pong, and the pong agent always is in the idle state, and it can receive a ping. This symbol means that the message that it can receive. And here he makes some animation. That symbol is to set a color on. We will see now running the example. And here, what this symbol is sending a message, and idle is the state. So SDL, the symbols that SDL has are states, income messages, outcome messages, and procedures or some operations we can do. Messages can have some delay. So when we send a message, we can say, okay, you send message after this delay. And basically, this is the basic syntax of SDL. The symbol is the start. So when the state machine starts, all the different agents executed starts execution with a start label. And then here, that means that after a start, it goes to idle state. And here they can switch from idle to running, and Pong only remains to the idle state. Okay, this is the specification in SDL. If you want work with these diagrams, there are some tools, and there is a very interesting tool called Umletino. Umletino is an online tool for diagramming in general. It's intended to use with UML, but you can use it for drawing SDL diagrams. And what we can do, I can copy here. If I copy this link, and I have this link copied, and then open Umletino, and I open Umletino in another tab. And here I start Umletino. What I can do is import the diagram. I copy the URL, and then I have here the diagram. Okay, so we can modify. I can, for instance, add a new state. But if I make a double click, I can state here. Okay, so I have the possibility to draw in a very agile way SDL diagrams. This tool, I cannot customize the palette, this palette, and adding here, for instance, SDL, an SDL entry. There is an offline version called Umlet that lets you to customize your palette set. But one trick that we can do is open another tab. And here there is a URL of the palette. So I can open another tab. I can import this URL. And here I have all the blocks, SDL blocks in one block, and I can copy it. And if I make some room and I paste, I have the palette. So it's a trick to work as if I have a palette. So here I can make a start and then improve my diagram. And at the end, when I don't want the palette, I can delete and I have the diagram. Okay. This is what about related to SDL. What we have done is a process to map these SDL elements to snap elements. Okay, so if I click here the Hello World link, we have this example. Well, we have to check JavaScript extensions. Okay, and here we have the same example written in SDL. So let me show you. Here. This is a paper that I'm writing now about this extension, and here we can see the mapping. So we have some SDL blocks that snap blocks that let you translate directly the SDL symbols to snap symbols. And here we have the environment. This is the environment block. So this is this one. So we have here start, send M star message to ping, and go to idle. So if I read here, start, send signal M star to ping, and go to idle. The second agent is this one, and we can, I think it's better see the comparison here. It's not at the same level now. But we have here the ping agent, the ping process. We have start goes to idle, and then if I am in the idle state, when I receive mstart, I send ping to pong and I go running. We can see here. When I am idle, if I receive start, I send signal mping to pong, to p-pong, and I set state and I go to the state running. When I am running, if I receive mstop, I go to state idle. If I receive mpong, I make the animation and I send the signal t-wait to self and I go to running. So this is a direct translation from this diagram to snap. And finally, this is the pong, the last. So it is in idle and always remain in the idle state. When I start, the execution, I see that these processes, they interchange the message ping, send a message to pong, and pong send a message to ping after 1 second. Okay. Well, this is a way to implement SDL models in Snap. What is why is interesting for us? In postgraduate courses about industrial digitalization, Industry 4.0, and so on, we have two different kinds of students that who they come from IT world, so they have no problem in programming, but more or less half of the students come from the operations world, or they do not come from the IT world, and they have programmed time ago, but they are not fluent in programming. So in many cases, they are scared about programming. And which is very interesting is when they use these low-code tools like Snap, Scratch, or these kind of programs, they engage with this programming very, very well, because they have the basic knowledge about structured programming, loops, or blocks, variables, and they can put into practice, no? Very easily. Let me show you an example of, for instance, here, of a practice that the students, they have developed in this way. Here there is treatment, a water treatment installation. And in this water treatment process, there are different stages, and each team developed one of the stages. In this case, this team have developed the filtration stage. So they make a research of information how these installations work, and they modelize the operation in SDL because they understand, they know SDL, and they define or specify the behavior in this formal language. And which is interesting is with these tools, they just can execute in a very non-visual way. And when they implement this in Snap, okay, we have, I make import. And if I load filtration, what happens? I want to, sorry, snap filtration here. They have built something like this. So they have done a mixture between the formula specification. So they have translated the snap specification using the rules. And then they have mixed with the animation blocks in order to make a simulator and visualize what is the process, and they can make a trace and analyze the traces of the simulation. And which is very interesting is they can connect, the different teams can connect their simulations using another extension called MQTT that lets send and receive messages between different browsers. Okay. Okay. I don't know about time. I think I have 2 minutes. Let me show you how to make some remote control on a simulation. For instance, okay. If I start here the simulation, I have the ping pong, okay? And then if I want to stop, I can send a message, stop. So if I send a message to stop, simulation stops, okay? There is a module extension that we presented the last SnapCon edition. It's called MQTT4Snap. MQTT4Snap lets send and receive MQTT messages between browsers. So if I open another browser and I go to MQTT4Snap extension, and here we have a hello world for MQTT for this extension. Okay, and here this block connect. Yep, I have to, sorry. JavaScript extensions, okay. I can connect to the browser, to the broker. Here I subscribe, I send a message, okay, it works. So instead of sending topic name, I will send start, for instance, start, okay. And here, what I have is, using the same block, I connect, I subscribe to topic start. And when I receive a message, here, what I do is to send an SDL signal to the system. So it's the same as if when I send start, I click here, start, and I send the start signal, it starts. And here, it receives the message from another browser and it starts. So let me confirm. Oh, here, sorry. We have here the other browser. So if I send start, oops. I have to connect, sorry. I send start. Okay, so it receives a message, and here the simulation starts. And if I send stop remotely from another browser, it receives the message. I have to subscribe first. And I send the message. Okay, and it stops. So, okay, this is what I wanted to show you. If you have any questions, So I will answer you. Thank you.